In this video, I'd like to talk about the math question of the day for Wednesday, June 21st, 2023. And with this problem, we're told that in the right triangle shown here, the measure of angle J is 60 degrees and the length of JL is 6 multiplied by the square root of 3. And we need to figure out the length of JK, which is denoted by X here. And questions like these are typically seen in a geometry class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And the key idea is to recognize that since we have a 60-degree angle here, a 90-degree angle here, we can figure out this missing angle, and this would have to be 30 degrees. Since 60 plus 30, that's 90, and 90 plus 90, that's 180. And all triangles, at least on a flat surface, have angles that add up to 180 degrees. So we have this special right triangle, a 30, 60, 90 right triangle. And these triangles are formed from equilateral triangles. So let's say we have some equilateral triangle, and it won't be drawn perfectly to scale. But if this is an equilateral triangle, then the three sides are all equal. And what we can do is split this triangle in half. Now I should also mention that because all the sides are equal, all the angles are equal as well, and they are all 60 degrees. But if we want to split this in half, we can drop this perpendicular here. And again, this is not going to be drawn perfectly to scale, but by splitting this in half, each of these will now be 30-degree angles, and we would have 90-degree angles here and here. So notice that by splitting an equilateral triangle in half, we end up with a 30, 60, 90 triangle like we have here. And we can figure out the relationship between the side lengths of these 30, 60, 90 triangles just based on the larger equilateral triangle. So let's focus on one of these triangles, and let's call these side lengths A. So that would mean that this small side here, since this was split in half, this would be A over 2. And we can also figure out this vertical side here, which we can call H. We can figure that out using the Pythagorean theorem. So we know that in a right triangle, if we square the two legs and add them together, we get the hypotenuse squared. And you might be familiar with a squared plus b squared is c squared. Try not to confuse this with this letter A. These are just typically the letters used, but we could have called it x squared plus y squared equals z squared if we wanted. But the main idea is that x and y, or a and b, these are the legs of the triangle next to the right angle, and either c or z, depending which of these you want to use, that is the hypotenuse. So we square the legs and add them together, and that's equal to this hypotenuse squared. So let me remove this here so that we don't confuse the lettering. It's just, I probably should have chosen something other than a there. But let's actually carry this out. We have a over 2, that's one of the legs. We'll square that, and we'll add it to the other leg squared, and this is equal to the hypotenuse squared. And we want to figure out what h is, this vertical side, so that we can relate all three of the sides in this 30, 60, 90 triangle. And if we square this out, we get a squared over 4 plus h squared. This is equal to a squared. Let's solve for h, so we can subtract this on each side. And we could write this as 4a squared over 4, and we're subtracting 1a squared over 4, so that we get 3a squared over 4. And the last step is just to take a square root of everything, and we are only concerned with the positive rather than the negative solution because we're dealing with physical side lengths. So we get the square root of 3a squared over 4, and we can take a square root of the top and the bottom since we have a fraction here. In the bottom, the square root of 4 is just 2, and up top, the square root of a squared, that's just a, and we get root 3 multiplied by a in our numerator here. And we just can't take a square root of 3 without writing it as an irrational number. So this vertical side here is root 3 over 2 multiplied by the long side, the hypotenuse, of our equilateral triangle. So we can now figure out what our missing side is. And frankly, we didn't have to do all this work because we don't need to know what LK is, the side opposite the 60-degree angle, since that's what H is. We need the side opposite the 30-degree angle, which is just half the hypotenuse. So we could have recognized that early on, but it is helpful to know this relationship so that if you do need to know the side length opposite the 60-degree angle, you can find that. It just comes from the Pythagorean theorem. And recognizing that whatever the hypotenuse is, the shortest side is half that. And once you have two sides in a right triangle, you can figure out the third side. So x is just half of 6 root 3. So let's write that in. We have that x is really just our hypotenuse divided by 2. So this simplifies to 3 multiplied by the square root of 3. So this right here will be our final answer for the length of JK.